Hello, sixth graders. I really miss you. I want you to know I'm praying for you, and I hope that everything's going well at your house. Before we start on lesson 8.4 on proportions, I want to do a really quick review of slope. I'm checking homework today that gets sent to me via photographs on email. I'm recording this video actually on Tuesday, March 17th. So slope is still in my mind. I want to give you a quick review of the difference between positive and negative slope. Positive slope will climb from left to right, and negative slope will go down from left to right. So this is a positive sloped line, and this is a negative sloped line. We also talked about a zero slope, which is a horizontal line, and undefined. So some teachers call this a slope tree. If it helps you to keep the difference between positive and negative slope in your mind, then remember the slope tree. If you just think that's ridiculous, you can forget it. I would encourage you at this moment to pause the video and do a little exercise that we did in class last week, where your right hand is up above you and your left hand is down below, and go through our chant of positive, negative, zero, undefined to remind yourself of the different slopes. One more thing is, if you are given a negative slope and you have to plot it on a graph, which I do not have graph paper right now, so just be patient with me because my lines are not going to be very straight. If you're given the point 2, 2 and a slope of negative 5, negative 5/6, then to count the rise and run off so that you can mark the second point and draw a line, you would do that by noticing that this, I'm going to use my numerator, my rise, I'm going to go down because it's negative. So from the 2, 2 point, I would go down 1, 2, 3, 4, 5, and then I'm going to go to the right 6 units because it's positive. So I can't go back to the left because then I would have 2 negatives, which gives me a positive slope. So I would go to the right, and I don't have all my hash marks written out, but I would go to the right 6 spaces, 1, 2, 3, 4, 5, 6, plot a second line, and connect them. If this is still confusing to you and you've watched the Khan Academy and the other video that I sent to you, please let me know because you do need to know how to do this. All right, moving on to proportions. I have off to the side of me my lesson plans that I put in for Wednesday, and I'm going to be referring to that as we go through this. You will notice that on RenWeb it says that proportions are the same thing as equivalent fractions, which we've already covered. So hopefully as we go through this, some of it will sound familiar to you, and this should not be that difficult of a lesson. So I'm looking in the math book on page 418, lesson 8.4, and I'm just going to go through the 3 examples there and maybe give you some guided practice examples as well. And then we'll go from there. So if you look at it, example 1, it says that it's referring up to the little storyline above about sports. It says a person burned about 210 calories while inline skating for 30 minutes. So I would write on my paper 210 calories for 30 minutes. And then it continues by saying, about how many calories would the person burn while inline skating for 60 minutes? So I can set up a proportion. I'm trying to figure out how many calories this person burns if they skate for 60 minutes. And you will see that the definition of a proportion is an equation, which I've written out, that states two ratios are equivalent. And we see that they will be equivalent because of the equal sign in the middle. So I'm going to go through the methods that the book shows you to solve this, all right? And I'm actually going to end up going into 8.5 because my favored way, and I know Ms. Winfrey prefers this as well, is to just do cross products. But sometimes there's an easier method, and we'll also be referring back to when we did equivalent fractions. And in 8.4, most of them you can use this easy method. And that is looking to see how we went from 30 to 60. And how do we go from 30 to 60? Well, we multiply it by 2. And as long as we do the same operation to the numerator that we did to the denominator, we can solve for the variable. So if 30 times 2 is 60, then 210 times 2 will give us C. And 210 times 2 is 420. So we would know that you would burn 420 calories if you inline skated for 60 minutes. Okay, moving on to example 2, which is going to use algebra. We've talked about it before. This goes back, I believe, to chapter 6. Not positive about that, but you could look it up in the book if you needed to. All right, the example 2 is just the proportion 6/10, and an equivalent fraction or ratio would be x over 25. Now, notice that in this one, we cannot just say, well, now I know some of you would know exactly what to multiply 10 by to get 25, but I'm trying to keep it simple here. If you want to multiply it by what you would multiply it by, then go ahead. If you multiply the same the same number to 10 and 6, you will get the correct answer, but I am working through it the way the book is. And so they are saying that if you multiply each side by 25, now why are they saying this? I'm going to I'm not. I'm going to show you, I'm going to remind you of what we did in chapter 6. I believe it was the beginning of chapter 7. Here we have a variable. Remember that our goal is to get this variable alone. Okay, why is it not alone? Because it's being divided by 25. So I can do the inverse operation, which is to multiply it by 25. But to solve an equation, I need to multiply both sides by 25. Okay, that gives me x by itself on the other side, on the right side. And 25 times 6 is 150 over 10. And I can do that division problem and find out that x is 15. All right? That's a second way to solve proportions. All right, let's look at guided practice. Let me clear my board off. And we will do guided practice number 4. 9 over n equals 99 over 22. All right. In this one, I can see that I can easily go from 9 to 99 by multiplying by 11. But can I multiply n to 11? No, that's not going to help me any. So backing up, that's not going to give me an answer. What else can I do? I'm going to look at it sort of in reverse. Because my complete fraction without a variable is on the right, I'm going to see how would I go from right to left, okay? If I divide 99 by 11, and this is not correct math. 9 does not equal 11 divided by 99, okay? But we're just working this out mentally, and I need to write something down, so stay with me. 99 divided by 11 is 9. And 22 divided by 11 is 2. So we would know that n equals 2. All right. Let's look at one where we can't work it out as simply as that. And I'm just going to drop down to number 8. If you want to do some more of the guided practices, grab a pen. Hopefully you already have a pen or pencil in your hand. I'm going to quickly give you the answers to 1 through 3. And then you can work them out and see if you're getting them right. Number 1, you should get the answer of 4. Number 2, 48. And number 3, 36. Also, number 5, you should get 14. Number 6, 10. Number 7, 11. And I'm going to work out number 8 with you. B over 8 equals 7 over 28. Okay. Again, there's no easy way to go back from 28 to 8. I can't just divide by an integer. So I am going to do the algebra method that we learned in chapter 7. And I'm going to get my variable alone. Okay, and that means that I'm going to do the inverse operation of division, which is multiplication of an 8 to both sides. Okay, that leaves B alone, and the other side becomes 56 over 28, which I just need to simplify. And some of you might realize that 28 will go into 56 twice. That is just a division problem. All right, that's how you can solve for proportions in 8.4.